What is a list? A list is a built-in data structure in Python which is used to store collection of items. These elements are stored in a defined order, and this order will not change unless it is explicitly modified by you. Mutable is you can modify the list after creation. You can add items to the list, you can remove items from the list, and you can change the items. This is called mutability. And another important feature of list is it can contain multiple data types. For example, if you consider the list which is defined here, there are numbers, there are strings, and there are floating numbers. So a list can contain any data type. We can create a list just by simply placing all the items inside square brackets. It's as simple as that. Let's say I have a collection of integers. So the int list is a collection which begins with a square bracket and ends with a square bracket, and it contains all integers. And I can have a string list, let's say Python, Java, SQL, MongoDB. That's it. Okay, once we create a list, how can we access the items in the list? To access items from the list, we should know something called indexing in Python. Now, I should have a way to communicate to Python that I want to access the fourth element or fifth element or sixth element. Now, how does Python know? There is something called indexing. Of each item is based on an index. Python follows something called zero indexing. The first item is at index 0, and the second item is at index 1, third item is at index 2, and so on. To access the first element from the list, I simply have to mention the index number within a square bracket. If I want to access the first item, I have to put the index 0. As we can see here, the output is 1. If I want to access the fourth item, the index should be 3. The fourth item is 6, so the output is 6. Now, if the list is too big, let's say it has some 100 elements, and if I want to access 98th element from the list, it's very difficult to count the position of the item by looking at the list. In such cases, Python has given a flexibility of negative indexing. Let's say I want to access the last item from the list. So in this particular list, if I want to access the last item, the index is 6, but the negative index for that item is -1. If I want to access the item before the last element, it has a negative index of 2. The output is 9. These are the two methods to access the items from the list. What is slicing? Slicing is used to access a portion of the list by specifying a start index, an end index, and an optional step. How to do that? We have to specify the list, and within square brackets, we can write the starting index, the index where the slice should begin, and stop index, the index where the slice ends, and a step. Step is the interval between each element and the slice. What do I mean by that? Let's say this is my list. If I want to access the 3 items 5, 6, 8, how should I slice it? So I should first write the name of the list, and within square brackets, what is the start index of 5? It is 2, right? So 2 colon, and what is the index of 8? The stop index is important because this index is exclusive, it's not inclusive. So 8, the index of 8 is 4, right? But since stop index excludes that index, we should write the index as 5. So the first index will be written as it is, and how many items should I access? 3 items, right? So 2 plus 3, 5, and the index is 5. The step by default is 1, and since it is optional, we can ignore it. So what will be the output for this? The output is 5, 6, 8, right? Let's say I want to access 8 and 9. How would I access them? So print int list, and what is the index of 8? It's 4, right? 4 colon, and how many items should I access? 2, right? So 6, because 6 minus 4 is 2. So this slicing contains 2 elements, which is what we want. So we got the output as 8 and 9. It starts at index 4 and stops at index 6, but the index 6 is exclusive. Let's say I want to access items from 5 till the end of the list. For that case, I should write the index of the first item, which is 2, colon, and I need not specify my end because I want all the elements starting from 5 till the end of the list. I need not mention the stop index. As you can see the output, it printed the items from 5 till the end of the list. So the list can be as big as it can be. If I don't mention the stop index, then Python assumes that I want all the items till the end of the list. That's why it gave an output of elements starting from index 2 till the end of the list. Slicing from beginning to a stop index. Let's say I want all the elements from the beginning of the list till a stop index. If I want to access these 4 items, then so I'm leaving the first index as empty, colon, and the second index or stop index depends on how many items I want on the list. Let's say I want to have 4 items, then here the stop index would be 4. The fourth index is exclusive in Python. Because the fourth item of the list has an index of 3, I should write the index of 4 here because 4 is not included. Because the stop index is exclusive in slicing. As you could see, we could get the first 4 elements from the beginning. Now slicing with a step. Let's say I want to access every alternate element from the list. How do I do that? The item should start from the beginning and I want the first 5 elements, but I want every alternate element. So every alternate element, the step will be 2. As we could see here, the first item is selected and then it took a step 2 and took item 5 and then took a step 2 and took item 8. Negative index slicing. As we already saw previously, the indexes can be positive or negative. So negative 1 is the first item from the last. Negative 2 is the second item from the last. Negative 3 is the third item from the last. If I want to slice the items using negative indexing, how do I do that? Let's say the start index is -3 and I don't mention the stop index. What does the output of the cell be? It would be 8, 9, 11. 11 is -1, 9 is -2, and 8 is -3 index. So when the beginning index is -3, it took the first item. And since I did not mention the stop index, it took all the elements till the end of the list. That's why the output is 8, 9, and 11. Let's say I don't mention the start index and mention the stop index as -2. What does it output? Excluding the item with the -2 index. So the output is the items from the beginning of the list till negative index 2, but excluding that index item, that is 9. So it gave items till 8, 1, 3, 5, 6, and 8. Slicing with both negative start and stop index. Let's say the start index is -4 and stop index is -1. What does it output? Firstly, the number of elements would be 3 because 4 minus 1 is 3, and the negative index, the last item or negative index 1 is not included. So ideally, it should give these 3 items. Let's see. As you could see, we could get 6, 8, and 9. What happens if we slice using both positive and negative indexes? Let's say the start index is +1 and the stop index is -1. So it starts from index 3 till the end, but excluding the item with negative index 1. So it should ideally give 3 to 9. As you could see, we could get the items from 3 to 9. Slicing with a negative step for reversing a list. For that, we should write the syntax as I'm not mentioning the start index, I'm not mentioning the stop index, but I'm asking it a step of -1. So in this case, the entire list is reversed. So the first element became 11, 9, 8, and so on. So this is a way to reverse a list by using slicing. Let's say I want to access these 3 items from the list, but I want to have them in reverse. That means the first item should be 8, the second item should be 6, third item should be 5. For that, I'm using the command int list. So the first item should start from 8, right? So it is a negative index of -3. It should start from there and then it should go till -6 and it should be in reverse. So I access these 3 items in reverse. I could also use a combination of positive and negative index for this. So the item starts with -3 index and it ends with the 0, 1, 2. So the positive index of 5 is 2. But since 2 is not included, it should be 1. We got the same output. So these are the different ways to slice the list. Modifying lists. I have a list of items. Now I want to add a single item to the list. How to do that? For that, we use a list method called append. Let's say I have the int list. So I want to append 12 to that list. As you could see, the 12 is added to that list. Let's say I want to add it at index 1, or the second element should be 12. How to do that? So for that, I use a method called insert, which takes in two arguments. The first argument is the index, where you want to insert it, and what you want to insert. Let's say I want to insert 13 at index 1. So how to do that? Simply int list dot insert at index 1. I want item 13. As you could see, the item 13 is added at index location 1. If I want to add it at index location 4, let's see what it results. 13 is added at index 4. What if I want to add multiple items to the list? For that, we use another list method called extend. Int list dot extend. Let's say I want to add 15 and 16 to this list. I just print the int list. As we could see, we got items 15 and 16 added to the list. I have a list of items. Now I want to remove the last item 16 from the list. Since the list is very small and I could see the item, I could simply remove this item based on the value. The value of this item is 16, so I could just remove it by using the list method called remove. So how to do that? Just need to use the method and 16. Now print int list. As you could see, the 16 is removed. Suppose the list is very big. It's very difficult to look at a specific value and then remove it. In that cases, we may have to remove the item based on the index of that item. So in that case, we could use the delete function to delete a specific item of the list based on the index. Let's say I want to remove the last but one number of the list. So the negative index for that number is -2. Let's print the result. As you could see, the item 11, which is at an index -2, is removed in the final list. What if we want to clear all the elements from the list? It's very simple. We just need to use a method called clear. Let's print the int list. As you could see, it returned an empty list because all the items are cleared or removed from the list. Let's say I want to remove an element from the list, but I don't want to trash it. I want to use it somewhere in the program. In that case, there is a method called pop. What pop does is it removes an item at a specific index. Now we can assign that to a variable and we can use it somewhere in the program. Let's see how it works. Let's say I want to remove this item 5, which is at index 2, and I want to use it somewhere. So the removed element is intlist.pop, and I can specify the index of it here. The index is 2. Now print my removed element and also print int list. Let's see. The removed element is saved here and the list is modified with 5 removed. What if I don't specify the index? If I don't specify the index, the pop will remove the last item from the list. What do I mean? So int list, this is the modified list, right? So if I use dot pop and then print the int list, we could see that the last item is removed and int list is saved with the last item removed. These are the different ways we can modify the list. We can add or remove items based on different methods which are defined in Python. Find the index of an item. Index of item 2 is the name of the list dot index of that item. Index of 2 is 1. If you look carefully, there is 2 at index 1 and also at index -1. If the element is repeated somewhere else in the list, that index is not picked up by Python. Index method returns the index of the first occurrence of the specific value. Now I want to count the number of times 2 has repeated in the list. So I'll use the count method. 2 is repeated 2 times in the list, so the output is 2. Next comes sorting elements in the list. Let's say this is my list and I want to sort it. If I use the sort method, it will automatically sort it in ascending order. So int list of sort, the list has been sorted in ascending order. What if I want to sort it in descending order? If you give the argument reverse is true for sort method, the list will be sorted in descending order. Now there is sorted function as well. The sorted function takes a list and returns a new list which is sorted in ascending order. If this is my list and I want to reverse it, then I can use the reverse method. Int list dot reverse. You could see the list is reversed. We can use the reverse function as well. The reverse function gives a iterator object, and if you want to have that in a list, then you have to finding the length of the list. This is the list. The length of the list is the number of items in the list. So if I use the len function, I'll get the length of the list. If I use the sum function, I'll get the sum of all the elements in the list. What if I have strings in the list? What does the sum function give if I have strings in the list? If I have a combination of strings and numbers, and if I try to calculate the sum, it gives a type error, unsupported operand type for int and string. Finding the maximum and minimum of a list, we could simply use the min and max functions. Max int list, max number in the list is 11.2, and minimum number is minimum number is 1. What does Python give if I have strings and numbers and ask for maximum? Again, it's a type error. It is not supported between instances of integer and strings. Nested lists. Nested lists are lists that contain other lists as its elements. If I want to access the element of a nested list, which is like a conventional list, so nested list of index 1, if I want to print out, it is 4, 5, 6. Even if I want to pick the second element of this list, how to do that? So print nested list of index 1, and in that list which is picked up, I want the second element, which is also the index of which is 1. Output is 5, which is at index 1 location inside that nested list. Concatenating lists. If I have a list 1 and a list 2, and I want to combine these two lists, then I can simply add list 1 to list 2. You could see all the items from list 1 and list 2 are included in this combined list. This is called list concatenation. Checking membership in lists. I have a list. I want to check whether item 3 is there in the list or not. To check that, I should write 3 in list. If 3 is there in the list, then the output would be true. If 3 is not there in the list, then the output would be false. Since 3 is there in the list, we should get true. We got true. What happens if we check for 4? It is false. We can check for negation as well. 4 is not in the list, so it should be true. It is true. List comprehension is just an alternative to the traditional loops and append operations. It is just a concise way to create lists in Python. This is the syntax of list comprehension. Within square brackets, we should write the expression first. For item, item is the variable that takes the value of the element. From where does it take? It takes it from the iterable. What is an iterable? It is a collection of items like a list, a tuple, or range through which we can iterate. And then there is a condition, which is optional. If you want to filter the items collected so far based on the expression, we can use if condition. What are the advantages of list comprehensions? The first thing is it's just concise. It's brief compared to the for loops, and then it is very readable. And performance-wise, list comprehensions are faster than traditional for loops. However, there are some disadvantages. If we have very complex operations, list comprehensions are difficult to read and understand. And the memory consumption is very high if you have large lists because the entire list is generated at once. Let's say I want to create a list of squares from 1 to 10. What is the traditional way to do this? First, we'll create a empty list of squares, and then we use a for loop. I should take this squares list and append them with x into x, which is x squared. Or we can write x to the power of 2. And then we want to print squares. So the output is all the squares of numbers from 1 to 10. How can we use list comprehension for this? We can write the expression which is x squared x power 2 for x in range 1 to 11, and then print squares. We could see that we could get the same output with just this single statement. This is the power of list comprehension. Let's look at another example. Let's say I want to create a list of even numbers from 1 to 10. What's the traditional way to do it? We should create an empty even numbers list, and then we should write the for loop for x in range 1 to 11 if that x percent 2, which is nothing but the remainder, if that number when divided by 2 gives a remainder of 0, then you take that number and append it to that even numbers list and print evens. We could see all the even numbers from 2 to 10. How can we do the same thing using list comprehension? Even numbers are x for x in range 1 to 11 if x percent 2, which is nothing but the remainder, is 0. Even numbers. You could get the same output with just a single statement. Let's say I want to convert a list of strings to uppercase. Apple, banana, cherry. Convert all the strings into uppercase. So what's the traditional way? Uppercase fruits. Create an empty list for fruit in fruits. Uppercase fruits dot append fruit dot upper. We're using the upper method here. Print uppercase fruits. How can we use list comprehension for this? Uppercase fruits is open the square brackets, apply the method directly for fruit in fruits. That's it. Print uppercase fruits. You got the same result with this list comprehension. Let's look at another example. Create pairs of I comma j where I is from 1 to 3 and j is from 1 to 2. What is the traditional way? We'll create an empty list of pairs, and for I in range, because it is 1 to 3, the range should be 1 to 4. For j in range, because the j is from 1 to 2, take the pairs and append I comma j. Print pairs. For each item in these two ranges, we got the result of pairs. How can we use list comprehension for this? Simply pairs are, open the square brackets, you want the expression I comma j for I in range 1 to 4, for j in range 1 to 3, and then you close the square bracket, print pairs. We got the same result using list comprehension. Let's say I want to create a list of numbers from 1 to 30 that are divisible by both 2 and 3. So what's the traditional way? Print divisible by 2 and 3 list. 6, 12, 18, 24, 30 are the numbers which are divisible by both 2 and 3 in the list of numbers from 1 to 30. How to use list comprehension for this? We just open square bracket and write x for x in range 1 to 30. And what is the condition? If x percent 2 is 0 and x percent 3 is also 0. It should be range 1 to 31, because only if it is range 1 to 31, it includes 30. If I write range 1 to 30, it does not include 30. That's why we got the output as different. But if I modify this, I would get the result same as the previous one. Using functions in list comprehension. Let's say I have a function here and I want to use that function in a for loop. Traditionally, what we can do is define the squares as empty list for x in range, let's say 10 numbers, so range 1 to 11. Take that squares and append it with square of x. Print squares. What we did here is we used a function instead of using an expression, and that function is defined somewhere in the program. We could use list comprehension to do the same job. So using list comprehension, squares is take that function square of x for x in range 1 to 31. Sorry, 1 to 11. And then print squares. We got the same result. So these are the different ways we could avoid the traditional for loops and use list comprehension to have a concise code and do the same job with more efficiency.